Hi, my name's Matt. I've been a software developer for more decades than I can count, actually. And I have a particular fondness for Unix APIs and all the different things you can do with them. And one of the things I've noticed a lot lately, especially like the Internet of Things, there's a lot of security vulnerabilities revolving around people running external commands and then having the whole system owned by somebody supplying some bad input to it. So this is about that. This is a brief introduction to that and how you can easily avoid the worst cases. This particular vulnerability is called command injection. Now, I think most people who do web programming in particular know about SQL injection. There's been a really famous comic strip about it. I'm sure a lot of people have seen here, Little Bobby Tables. The basic idea is that, we're expecting an ID, a number, and instead we supply you maybe a number and a semicolon and drop table, or we insert some new passwords into the table, something like that. So, most people avoid that by using frameworks that specifically take care of all the data massaging so that it's impossible to inject extra SQL that the SQL interpreter is going to interpret for you. But of course, SQL isn't the only place you can get code injected. So here's an example. I use Python for these slides, but it's really quite relevant to lots of different platforms and languages. This is not a terribly contrived example, although I just noticed it's missing a space. This is from a system that, given a host name, is going to do a ping on it to see if it's alive. This is actually fairly slightly modified from a real system I did work on. And in the happy path, somebody passes in a host name, 8.8.8.8, one of Google's DNS servers. We execute the system command, and it returns a success or failure based on whether it can ping the server or not. So, hey, that's great, it works, it passes our tests because we wrote tests around this. But what we didn't test for is that somebody's going to come along and do this. And once we concatenate those two strings together, we're telling the system command, which is just taking a big long string of what to do, hey, ping this, and when you're done, start removing all the files on the server, because, we don't need it anymore. The reason this is a problem is because the system command, having taken a full string like this, pipes everything through the shell. The shell is a programming language itself. It's going to take what's data and interpret it as, a programming language. Now, in this case, we're kind of just like splitting it up between, the two commands here that will run in sequence. If you have a vulnerability like this in your software, you can do a lot more than just run another command. You can ask the shell to make a remote connection to your server and give an attacker shell access into your system to do whatever else they want. So, bad stuff all around. And all you really wanted to do was just let somebody ping a host to see if it was up. What can we do to get around this kind of stuff? In Python, there's a library called subprocess, but you'll find in just about any platform, there's something equivalent. The key thing you want to look out for is that instead of a big string, it takes a list of strings, or an array. In Node, I think it's, which I've been doing a lot of lately, the child process module has one called spawn, which I think takes a list of strings. The idea being here is that this is a more direct interface to the operating system. And it's going to directly feed this list of strings right into the entry point of the program you're calling. So, at the beginning of every C program, you have int main, which is the entry point. argv takes, this whole list of things. And they're not interpreted, they're not being processed, they're not being looked for code. They're just flat out string arguments. So when somebody tries to do our little RMRF, it just comes in as our hostname argument. Ping's going to try to look that one up, explode because, hey, that's not a valid host name, and we're fine. We blocked the attack, in effect. This is the single most important thing you can do to avoid this kind of attack. There's a couple other considerations that you should look out for too. These are less often a problem. If your path is under the control of an attacker and might be under the control of an attacker for some reason you're not totally clear on because of some other vulnerability, you can substitute ping for some other command. So, what you can do to solve that one, instead of putting ping up front, you put /bin ping to explicitly which ping I want to run so that the path command doesn't affect it. In some cases, it pays to really know the program you're invoking. The environment can affect how your program's executed. So there's a number of variations on this call pattern with the list that can take an environment argument, and you can just feed it just an absolutely minimal environment to avoid this kind of thing as well. Keeping it short, but if you want to find more up on this topic, pull open a browser and search OWASP command injection. They've got a good page on some of the stuff I talked about and a lot of other kind of interesting incidental attacks. And yeah, it's a pretty good resource, OWASP, for all sorts of vulnerability issues. So that's what I got. Thank you.